Hey everyone, Chris here. Now we're actually going to start coding our component system. So first thing you want to do is you're going to want to create a new project, and you're going to select an empty project. Just give it a name. I'm going to call mine component system. And then I'm just going to stick it on a folder in my desktop called recording that I have set up. Alright, so you're going to create that. Now create your empty project here. So you're going to want to create a few files just to start this off, and I'm just going to pause the video here, create the files, come back, and I'll explain them. Alright, so I'm back now, and I've created a bunch of classes here, as well as created just a main.cpp so that we can eventually test this stuff, because we're not putting this in a DLL at this time. Alright, so the classes I've created so far is I created a component class, a GameObject class, and a component manager class, and those are really the three core classes for this. With the component class, you can't use the class creator. You're actually going to have to create them individually because component is a reserved word. But other than that, I just use the class creator to create these. So let's get started working on the component class. Alright, so there's a couple things we're going to do here. First of all, we're going to include a string, so that we have that there. We're also going to want to declare GameObject here, and then we're going to go over into the CPP and include GameObject there, and this is just so that we can reference GameObject in component and reference component in GameObject. Alright, now we're also going to want to add another constructor here, and this one is going to take a standard string, and we're just going to call this lname, and we're just going to take that, copy that over here, and just leave it there for now, and we'll come back to it in a little bit once we finish writing the rest of this header. Alright, we have to make the destructor virtual for polymorphism. I'm not really going to explain why that is, but you do have to, so make it virtual. We're also going to create a couple member variables here, and as I said earlier, we're not having anything private, so just create a string for that's the name, create a GameObject pointer, and that's just going to be the GameObject, and then create a bool flag for is enabled. Now let's go on to creating the function prototypes. So we're going to create a bunch of virtual functions here. We're going to start off with destroy. These aren't created in any particular order. You can put them in however order you want. I'm just writing them in this way because that's how I feel like it, really. Alright, and we have an awake function. Oh, forgot the void there. Let's go back, add that in. And then add a start in there. So this class itself is mostly going to be empty. We're not really going to have much going on in here, mainly because this is a base level polymorphic class. We don't need a lot of stuff in here. That will come in the child classes. You're also going to want to add the fixed update, not updated. And forgot the void again. It's the virtual, it's throwing me off. I'm typing V twice and I think I'm done. We're going to add in the update and the late update that we discussed. We're then going to jump, first before we jump over there, we're going to copy all these functions here, and we're just going to bring them over to our CPP file, remove the virtuals, and I'm just formatting these as I go, and remove those semicolons. And you can just get an idea of how I do my coding style. I write the headers, I design the headers, then I write them. Then I copy them over to the classes so that we get functional classes. And I just format as I go, and then I go through after and comment. But for the sake of this video, I won't actually be going through and commenting this stuff because I'm talking about it as I work through it. Alright, so there we go. There's everything there. Just make sure I get the constructor there, have it. So I'm just going to take a quick break here and we'll be right back. Alright, so we're back. I was just looking at my notes over here, just setting them up so that we can work on this class. So first thing we're going to do is we're going to write the default constructor here, and the first thing we'll do is we're going to set this name. We're just going to set that to component. We just can give it a name so that it's not empty. Then we're going to set this enable to true, and this is just so that every game object is automatically enabled by default. We don't have to worry about the user having to turn on each game object. They can now turn them off when they don't want them and manage those rather than having to turn every component on. And we're also going to set this game object, and we're just going to set that to null, all in caps there. And that's just so that it's good practice to set all your pointers to null when they're not in use. That makes it solves a lot of you'll get a lot of weird errors sometimes when you're debugging strange issues. So it's better just to do it that way, and then you know it's taken care of. And the last thing we're going to do here is call the awake function, which will propagate through all the polymorphic hierarchy, and call the awake function. So I'm going to take a quick break here. When I come back, we're going to go over the GameObject class. Oh, I actually forgot one thing. We didn't actually set up the other component one, but it's really quick. All we do is we take what we had in the default constructor, copy that down, and replace the component string with the L name. Save that, and we're done. So now you'll see me again. It'll be the GameObject class. Alright, so we're back. Now just one other thing I forgot before. In the component here, I was missing the public here, so just make sure you add that back in so that everything's public. Otherwise everything's private there and it won't work. Alright, so now we can jump over to the GameObject class. We're going to want to include a couple things up here. We're going to include string. We're going to include algorithm. We're going to include type info, and that'll be useful for one of the features we'll have. And we're going to include vector, and that's for storing stuff. Alright, so the first thing we're going to do is we're going to just set up some fields here. I'm going to set up a name field, which is non-unique as well, same as the component. I chose to go with non-unique names because I don't want to constrain the user in that way, and it's really not that much effort to add non-unique names. So we're also going to add a GameObject pointer, and this will be called parent. And before we go on to the next section, we also have to add one more include, and that's going to be include components, or component rather. And the reason we did the pre-declaring before is because so we can include component this time. So now we're going to set up some type defs, and these just make life easier for you in the long run. You won't have to write out the std vector component pointer every single time you want to have it. You can just create a type def, call it component vector, or give it a shorter name if you want. I still give the fairly long name, so it doesn't save me that much. But you can give it shorter names if you want. I left them long names so you can see what's going on. We're also going to create type defs for the, or not that. We're going to create type defs off the component vector, and these are going to be the iterators. So we're going to create one for the standard iterator. And then we're going to go ahead after that and create one for the const iterator. And then once that's done, we can move on to the next step. So we're also going to just copy that stuff we had up there just to save my typing time more than yours. Feel free to type out. And this one is just going to be GameObject. And we can just rename everything here. It's much faster though. I find I'm not a very keyboard coder. I use my mouse excessively when coding. I find I go faster and it makes more sense to me. You may not find that, but really just follow along with the coding I'm doing, and that's okay. You don't really have to follow the same way I have actually writing my code. Now we're actually going to declare component vector, and we're just going to call this m_components. And I preface all my member fields with m_, any local with l_, constants with or const values with c_. If you notice, and then all my member functions are capital letter for the first letter of each word, and all my variables are camel case except for typedefs, which I name each word separated by an underscore just to differentiate it so I know it's a typedef. We're also going to want to create the GameObject vector here, and we'll just call that mChildren. It's really not mGameObjects, it's the children, and we want to give everything context names so that you can actually read through your code, there, and see what it is. It makes life easier a lot coding. I've actually seen some code that's been like condensed down into letters for code, and you really can't understand what's going on. So the next thing we're going to do here is we're going to create a second constructor, and we're just going to have this take in a standard string, and we're just going to call this lname again. You'll notice that I use the same names over and over again, so that if a variable is doing the same thing, it has the same name across all my code. This means you can come in, look at one file, figure out what it does, look at another file, and immediately pick up, oh, well, this is a name, and this is going to be associated with name. So I try and keep everything associated. So lname is always going to be passed into mname. And that way everything keeps nice and neat, and it's much easier on the eyes, and it's easier for a new person to come in and pick up. Alright, now we're going to create a create and destroy function. Then we're going to add a function that's going to add components. And this is going to take a component pointer. And we're just going to call that L component. Now we're going to have a function that returns a component pointer, and it's going to be find component by name. Now, as I mentioned earlier, components aren't unique named, but the GameObject, when we get to implementing the add component, it will have a section in there that actually restricts components, or restricts by type of component, so that there aren't multiple types of components in there, because you really don't want to have two renderers for a GameObject. If you're having two renderers, that should be two separate GameObjects. And since two GameObjects can be parented, you can have a GameObject parented to another GameObject, there's really no reason to not have that limitation in place, because they can just add a GameObject child to the parent and add another object on there. And that's really the way it should be. You don't want to be having too many components in an object, because then you get into just feature creep with the components, and you just make this super large GameObject, and it's just impossible to maintain. So the idea of the component base is to keep everything small, and so that's one of those things that ensures that. So this next thing we do here, I'm just going to scroll down a bit, this is going to be a templated function, and this is just going to, I use type name instead of class. It's the more modern way of doing this, although many examples still use class in there. I prefer using type name because I find class conflicts with the class for objects, and it's easier to read if you can tell it's something different. And so this is going to be a T pointer, and it's going to be find component by type. And this function is not going to be just have a function prototype. We're actually going to write this function entirely here. So we're going to take the component vector iterator and just have it in a for loop. I use iterators to go over everything, and it's really a good practice you should use. Again, I'm not really going to go into it. That's outside the scope of this. But you should definitely use iterators over just looping over the size of a vector. And so we're going to set iterator to begin. Then we're going to say iterator not equal to end, or m components end. And then we're just going to increment the iterator, and there we go. There's our for loop for incrementing over it. So this next little piece of code is a little nifty piece of code. Basically what it does is you're creating a variable of you're creating a variable of type t, and just call it L type, and then I'm dynamic casting it. And that's going to be of type t pointer. And just forgive my bad typing skills here. Sometimes they fail me, and sometimes I type really fast and really well. It's a little harder. It's kind of interesting trying to talk while typing. It's an interesting experience. So what we're going to have after the dynamic cast, we're going to dynamic cast the iterator, and we're going to dereference it there. So we actually get the value it's pointing at. And basically what this statement is going to do is, if the component is of type, if it's of the type, dynamic cast will cast it to that type, and the if statement will be true, therefore it'll go into the if statement, and we can return the L type. So the advantage of doing it this way is you could just have the dynamic cast and check to see if it would be true. But if you do that, you end up having to then do another dynamic cast. This way you avoid the second dynamic cast, and you can just return the type right there. And the code really looks nice. And then at the end of this, we just want to make sure we return null, and we will return null anytime we do a find with find any type of component, game object, pointer. We always want to return null if we don't find it. This way we can do a null check to see if it exists or not. So we're just going to write a few more functions here for the game object. We're going to write an add child, and this is going to take a game object pointer, and we'll just call it L game object. Oh, and we don't want to forget the semicolon on that templated function there. We're going to create another function here that returns a game object pointer, and this is going to be find child by name. And this is going to take in standard string L name, and then we're also going to create one that returns a standard vector of game object. And if you remember, we created, well, actually you can't use that, and I'll point this out, you can't actually return type defs because the type def is local to the class. Now if every class had that type def, or it was some kind of global, which you should never do, then yes, I'm pretty sure you can return type def, but I've never done it that way because you don't want to have a type def like that. The type def game object vector is only ever stored really in the game object and in the scene graph, which we will get to later and we talked about earlier. So I don't really like having a type def everywhere, so I just manually type it out here, and you only have to just type it out here, so it's not that bad. And this is going to be called find all children by name, and again we can just copy from above. It's just going to take standard string name, and there we go. And that's the end of that for now. There's still some more stuff we have to do here later, but we'll come back to that. So there's the game object header. Now we're just going to take all those functions we added, and we're just going to copy them over into here like we did with the component, and then we'll go in and we'll be ready to fill them out. And there is more code to be filled out in these than in the component, but that's okay, it won't take too long. So my plan is I'm just going to start formatting these now, and then I'll take a break and we'll come back and we'll finish them. We just want to make sure everything's set up right. No, not there. So we just go through this. Make sure we remove those semicolons at the end. Not doing them in any particular order here. Doesn't really matter. Nice thing with Visual Studio is it'll point out these things where you miss them really quickly. So that's very nice. It makes coding easier. I've tried coding in like simple IDEs, and I just don't really like them. I like the feature set that Visual Studio provides. It provides lots of tools in here. You can see up here when I was doing graphics programming, I actually have a GE debugger plugin in here, and that's really nice for doing stuff. But I think now I'm going to take a short break here, and then we'll come back and we'll start implementing the GameObject class. So I'll see you later.